Alright, so, a little bit of review, right? So I invest $4,200 at, let's go, 12% compounded monthly for, let's say, 5 months. So one thing I'd like you to do is to find out how much money I'm going to have in 5 months and do it exactly. And the other thing I would like you to do is find out how much money I'm going to have approximately. What's the difference between the two? If I ask you to do something exactly, what are you going to do? You are going to suffer a little bit, right? A long way, right? If I tell you to give it to me approximately, yeah, use the tables. All right, so how do we do this exactly? What's the technique? Multiply and add. Multiply and add. Multiply and add. Multiply and add. All right? Remember that the long way is apply simple interest, if I can spell the word right, each period. How many periods are in this problem? 5. Why? 5 months, and we're compounding monthly, right? So, period 1, period 2, period 3, period 4, and period 5. Alright, so, remember that it's simple interest in each period, so all I need is P, R, and T. What's my principal? The amount of money I started with, $4,200. What's my rate? 12%. Please tell me that it's 0.12. How much time is in this first period?
5 by 12.
How much time is in this first period? 1 over 12. Why? Because it's 1 month. It's monthly. So each one of these periods represents 1 month, which is really 1/12 of a year. Okay? That's a 1, I swear. So to figure out my interest, good old simple interest. The reason why I do this example another time is because it's reviewing chapter 10. Never hurts to review, right? 4,200 times 0.12 times 1/12. We'll get $42 in interest our first month. What do I do with that $42? Calculator criminal.
Yep.
What do I do with it again? Sorry? Add it to the original principal, and that's what starts your next principal. That's what it means to compound. So again, when you think compound interest, just think compound simple interest. So my new principal, after I take my $42 and add it up there, for the next period, is $42.42. What am I rating my time? The same, right? Again, the whole point of this is that we're rinsing and repeating with the same stuff every period. It doesn't change from period to period, so that's what makes it nice. All right? So our rate is 0.12, our time is 1/12 of a year. What's our interest this time? 42, 42. And again, the reason why it went up is because my $42 of interest that I earned in the first period earned me an extra 42 cents of interest in the second period. Keep going, right? P for the next period, add your 42, 42, 42, 84, 42. Cool number, by the way. Add the two outside numbers, it gives you the inside numbers. Oh, that's so cool. Sorry. I've had enough coffee that I'm ready. Alright, so interest in the third period. 42.84. Again, keep going. You haven't escaped yet. 43, 27, 26.
Yeah.
Okay, I'll buy it. Rate and time. Okay, I'm getting tired of writing them. What's my interest in my fourth period? So our number's steadily climbing, keep getting just a little bit bigger every time. Again, add it one more time into the fifth period. Principal in the fifth period. 43, 70, 53. Rate and time. Same thing. One last time. What's my interest in the last period? 43.71. Make sure you round things correctly. And then last but not least, add those numbers for our final value or our future value, i.e. how much we will have in 5 months. 44 something. 44, 14, 24. Is that what you guys got? Long way. Not bad, just painful.
It's easy, it's just 9%.
Yeah, exactly. And you have to be careful, right? So part of why I like to do a bunch of these examples so that you can see kind of how the growth happens, so that if you punch in a number and you wind up with, say, $424 here accidentally, right? So maybe you missed the decimal point or you added an extra zero or something like that, and you say, well, I started at 42 and now all of a sudden I'm at 420. Little bell should go off in your head saying, uh-oh. Try those numbers again, see if it works. All right? Now, if we do this approximately, how do we use the tables again? Be careful. We're going to start with 12%, but what page are we really going to go to? The page is how much interest we earn within each period, right? So in other words, it's the product of these two numbers, because these are the two numbers that we're always going to multiply our P by, right? So our time isn't 1 year, but it's 1/12 of a year, right? Since we compound monthly, our page, instead of being 12%, we have to divide it by 12 or multiply by 1/12, whichever one you like thinking about. We are actually on the 1% page, okay? So Again, the page is not the percentage number that I gave you, but how much that percentage is earned in each period, okay? So if you're compounding monthly, you're going to have to take this number and divide it by 12, always, okay?
So you take the first one divided by the percent? I was writing when you were doing that, sorry.
So the key is remembering that our future value is just the principal times the table entry, right? So that's how we simplify this. Instead of having to do all of this crap, all we have to do is find the one table entry and do one multiplication once. We're done. All right? The row is the number of periods. Remember, that's what the row is that you're going to look on. 5, right. Technically, you're going to say that this is 5/12 years, right? Because technically it's 5 months, which is 5/12. And when you multiply that by 12, there's 5 periods. Again, what I like to tell students is that these two things always happen together. Again, though, this one you should be able to look at it and say, I know there's 5 periods because I already did it the long way. Alright, so, to get the table entry, go to the 1% page. Again, the page numbers are now on the top. You are going to use the first column, and you're going to look on row 5. Does everybody see 1.0510? Perfect. Take that number, multiply by your principal, and this will give you the future value. And again, let me reiterate what I said last time, that the exact way gives it to you exactly to the penny, right? We got it exactly to the penny. When we use our approximation technique, we're close, but we can always be some digits off, right? Remember that only 5 of these numbers are going to be correct. This last 0, no guarantee.
What is that word right there?
Which one?
The one that's kind of scribbled by the 12% on this side.
Page.
Page.
Page over, yeah.
Oh, this? Yeah, this is page. So the two things that you always have to find in the table is what page you're on and what row you're on. All right. So, again, we're done doing the long way.
Does the homework ask for the long way?
It does somewhere. I can't remember if it's this chapter or the next one.
Okay. So just watch for it to say either approximate or exact. Or is
Yeah,
that just
uh-huh.
you?
I want to say that it's this chapter that says calculate it exactly and then compare it to approximately, but I can't remember to be 100% positive. I'll have to take a peek. All right, so how much interest will I earn on an investment of, let's say $6,750 at 6% compounded quarterly over 5 years. cool part about this particular question is that this is the exact amount of money that I invested into my Roth IRA 5 years ago when I started this job. So basically I took the money, the last amount of money I made from my real job before I came to this one where it's not real apparently, according to everybody else. And if
You're imaginary?
I guess. I mean, this is math, so maybe that's true. Anyways, what I want to know is, 5 years ago I invested this money. I have been making 6% compounded quarterly. How much is in that account? In this case, though, I just want to know how much interest did I earn. Because I want to be able to throw that money into a swimming pool and swim around in it. Because it's going to be lots of money, right? Because that's what you do when you have lots of money, apparently. Okay, well, whatever. All right, how are we going to go about doing this one? Again, you don't have to do it exactly. We're going to be using tables from now on. So, this is the technique you want to do it. First, tell me what the amount of money I put in initially was, right? So, $67.50. That's what I started with. The two things that I need to now know are page and row, so that I can find my table entry. All right, the page is basically what percent, so start with 6%. And now remember, you're going to divide by however many times you compound per year. Right? When we did it monthly, we had to divide by 12.
By 4.
Quarterly, that means we're going to compound 4 times in a year. Divide that by 4. So what page am I going to go to? 1.5, or the 1.5% page. Now, what row am I going to go to?
20.
Why 20?
Quarterly for 5 years.
Quarterly for 5 years. Quarterly means you're going to do it 4 times a year. You're going to do that for 5 years. So in other words, thinking about it like this, write down that it's 5 years, and that 4 quarters per year, times 4. Again, note, you divide on the top, you multiply on the bottom. That's this nice symmetry that should make you feel all warm and fuzzy. It does for me. So this is 20 periods, all right, or the number of times that we compound our money. All right, so now it's just a matter of read and rip, right? So go to the 1.5% page, go to row 20 and look at that first column. $1.3469, is that what all you guys saw? All right, excellent. And the nice part about it is, just multiply by your P. What was that?
909158.
So if I were to go back to that Roth account, which I tried very hard not to do, because if you look at how much money you have, you think you actually have some, that's really a bad idea. When you have money, what do you do with it? Right, so if you don't know that you have it, you don't spend it. These are very good things, wise things too. Hide your money as much as you can. I think that's why most of our grandparents hid it in a coffee can and then buried it in the yard. Right, I mean, that means that now they won't spend it, right? And they didn't trust banks back then, so they didn't understand compound interest, so. And it's safe, of course, it's now permanently safe. Unless you happen to have the treasure map. All right, so, unfortunately, what did the question ask for? I asked for how much interest. Is this how much interest I earned? Okay, because if I earned that much interest, I would be dancing around. This is how much money I have. This is the future value. How do you figure out how much interest you got?
Subtract principal.
Subtract the principal, right? So minus 6750, how much interest did I earn over those 5 years? 2,000 something? 41.58. So I earned $2,341.58, which is kind of nice, right? I mean, I'm not gonna throw away $2,300. That's for sure. I hope you won't, or I hope you will, and I'm working for you. All right. So again, the process is now available to you. All right. So let's see. So let's say I invest $4,000 at 7% for 3 years. How much will I have? So find the future value. All right, so what are you going to tell me here? Well, hopefully you'll start the same way that you did over here. What's P? P is 4,000. Okay, good. You know, guarantee yourself at least 2 points on the problem. I give you 1 for starting it, and another 1 for writing down what P was. Now, normally what would we do? Page in a row. We don't know how it's compounded, so why don't we know how much it's compounded? Because I didn't say. So what does that mean? If it's not compounded, what is it? Simple interest. So what are you going to write next with simple interest? Rate. Rate. What's my rate?
7%.
7%, 0.07. What's my time? 3 years. And what am I going to do? Multiply, right? Good old I equals PRT. Just because we've moved on to chapter 12 doesn't mean that chapter 10 isn't still there. Don't let me trick you, right? You're just going to be careful as much as you can. So using good old simple interest, how much interest do I earn? 820 bucks or something? 840. Okay, I'll buy that. And again, what did I ask for? How much I'll have. So technically you'll say, oh, that's the maturity value or the future value, right? 4,000 plus the 840, I'm actually going to have 4,840 bucks in my account. Again, when the word compounded is not there, it's simple interest. Okay, so don't forget that we did chapter 12. It's our friend. All right, now. I invest, let's go back to a nice easy number, $10,000 at 7%, but this time let's say it compounded daily. How much will I have in, say, 2 years? Oh no, let's actually do 2 years is fine, that's fine. So, you can have interest being compounded daily, and in fact, most of your savings accounts at a bank are actually using daily compounded formulas, okay?
0.1%.
Yeah, 0.1%, of course. Now, when you deal with compounding daily, so you see the word compounded, so you know you're going to use the tables. The trick about compounding daily is that there is a special table for dealing with compounding daily, okay? If you go to the very end of the tables, so after the 15% page, which is the highest page that the tables have, if you go 2 or 3 pages past that, again, it kind of depends on which year your booklet was copied. In my booklet, it's page 36, but the table should have at the top of it, interest on a $1 deposit compounded daily. Again, it kind of depends on which book you have, what page is yours. Could be page 35. For me, it's page 36. Go one more. There you go, page 36. All right. Technically, this is the table that you use whenever you see the phrase compounded daily, period. All right, there's no dividing by anything or multiplying by anything. You don't have to do any of that kind of crap. When you compound daily, all you do is use the special table. Okay? The method is the same. You're still going to take the principal times the table entry. It's just that getting to the table entry is just turn to this page, use this page. All right? So our P is the same. How much money did we put in there? 10 grand. Our page, technically our page is the special table. Again, I want to show you that you can follow the standard rules. It's just that, how many periods are there? Well, these are always yearly periods. So in this case, there's 2 years, right? So your job is to find the percentage along the top and then go down the number of years. All there is to it. Note that the smallest number in this table is 6%, which is ridiculous. If you can find a bank that's going to pay 6% compounded daily, please let me know. Yeah, because I would be in all of that. But the fact remains is that for this example, since we're making somehow 7%, go to the 7% column, go down row 2 because this is 2 years. 1.1503 and multiply by your principal. And we'll see that in 2 years, our 10 grand turns into 11,503 bucks. All right? So again, the key is just realizing that compounding daily, go to that special page. All right, so somehow mark this page so that you know where it is. Right, what I like to tell students is to get those little tab things so that you can put a little tab there that says special table or compound daily, so that when you go to do the test and you open up your book and you see compound daily, you'll immediately know where to go inside your tables. Have any of those sitting around in here? No, I don't. Bummer.
I have some.
Yeah, exactly. Those things right there. Perfect. Those are great. Right? You just put it on this page, write down whatever you need to write down so that you don't lose it. Okay? I mean, again, you guys know what's going to work best for you, but this is not a bad way to remember how to apply that. And do not be worried, folks. I will never ask you to calculate this exactly.
You just pass it around and try to get it.
That's a good thing.
A whole lot of
Yeah.
videos.
That would take a long time. All right, so Let's see. Any questions on utilizing the first column of the table?
Did anybody else want one of those tabs? It's right there if you guys do.
Thank you, Nikki. We appreciate it. All right, so we will come back to those, obviously. Before we move away from compound interest, though, I want to talk about a little topic, APY. Does anybody know what APY stands for? This is a phrase that you will see on every bank account that is advertised by a bank, always. You're almost right. All right. The A is annual, but you're right on the P, right? P is percentage. The Y is, again, this is an investment account. So normally when you invest money, you have a yield at the end of the year. So the APY that you will see written down next to bank account. So a lot of times they'll say the APY is 2.2% or something like that. Essentially what they're telling you is that the annual percentage yield is 2.2%. Simple interest. Okay? So, about 7 or 8 years ago, the federal government came along and they realized that, watching the banking industry, that a lot of us didn't really understand what compounded interest was. Even after they took a class like this. Although you guys won't forget, right? And so what they said, or they told to banks, was, look, Americans don't understand compound interest. We don't get it. Right? But we do get simple interest. We know that if we invest $1,000 and we invest it for a year, the amount of interest we earn is the percentage of that $1,000. So that level of percents we understand. And so what the federal government told all banks was that for any account that earns interest, you must tell them what the APY is, right? So you could say that it's 6% compounded quarterly. But then after you say that, you say, well, it has to be 6.14 APY, which basically says convert 6% compounded quarterly into simple interest. All right? So what we have to do is be able to do the same thing. So, let's try and figure it out, all right? I'm going to show you the long way, and when I'm done, I'm going to show you the super secret shortcut trick way, and you're going to laugh yourself silly and say, oh, excellent. Thank you, Marshall. You are all going to thank me, I swear. Okay? All right, so, I invest $10,000 at, and let's do that problem. 6% compounded quarterly. And I want you to be the bank and tell me what the APY is for this account. All right? Now, what we want to do, again, remember, we want to convert this percentage into simple interest rate. All right? How do we calculate the rate in simple interest? Review of Chapter 10. Exactly, right? Perfect. Good review. Way to go, Shelley. All right? So that is what we need. We need to know, one, how much interest does this account generate? We need to know what's the principal and what's the time. Now, the principal, how much is the principal? Okay. My P is $10,000. What does annual mean? Yearly, or 1 year. So how much is my time? 1 year. APY is always done over 1 year because that's what annual means. okay? So don't forget that you know what the word annual means, okay? It means year, right? So our time is 1 year. Oh crap, how are we gonna figure out how much interest this thing gets? Hmm? Well, we want it to be simple interest, but right now we have compound interest. How are we going to figure out how much interest we earn in this compounded quarterly account? Well, how did we do it over here? We used the special table, right? Well, what happens if I said it was compounded quarterly? What would you do? Divide what by 4? The percent. And then what would we use that as? The page, right? So in other words, use the tables. That's the reason we got them, right? So find I using the tables. Because unfortunately, we can't use the simple interest formula to calculate this because the interest is compounded. Damn. All right? So, P is 10,000. What page am I going to go to? Start with the 6%. Since it's compounding quarterly, we divide it by 4. We're on the 1.5% page. What row am I going to go to? Why 4? It's 1 year, so we're going to do 4 compounded periods. We are on row 4. What's that number? So my table is 1.0614. What do I do with that number? Multiply by the principal. Perfect. Principal was 10 grand. $10,614. Is that my interest?
Should be more than that.
That's my future value. What's my interest?
Isn't it 1,00614?
10,000.
The table? Oh no, that's just the L. Okay, my fault.
Yeah. This is the future value. We subtract our 10,000 to say that interest is $614. All right, so now we have P, T, and I. Slap it in there. So my rate in this problem is my interest, $614. Divided by my principal, which is 10,000, times time, how many years am I doing this for? 1. And again, you guys don't have to punch that in your calculator because you know what happens when you multiply by 1. Don't make it harder on yourself, right? Multiplying by 1 does not change anything.
So just divide the top.
Yeah, What is it going to give you? 0.0614. That's the decimal representation of your interest rate. What are you going to do? (6.14% APY). So a 6% compounded quarterly account will actually earn 6.14% simple interest each year. Now, 6.0614 or 6.14%. What do you notice over here on your table entry?
That is table. Same thing.
Same thing. Guess what? Yeah, it's always that way. Now my question to you is, or what I'm going to try and hypothesize to you, why this is true. Okay, why is it true that this table entry always gives me my rate? The reason is that after we got this table entry, what did we multiply by? The principal, right? And when we went to figure out the rate, what did we divide by? Principal. If you multiply the principal and then divide by the principal, what happens? Nothing. So technically, when you want to find APY, how much money there is doesn't make a lick of difference. Because you're going to multiply by it and then divide by it. Who cares? This could have been 50 billion. It doesn't matter. Right? Because you're going to multiply by it, then you're going to divide by it. It just goes away. And so the cool part about it is that to figure out APY, all you have to do is look up the table value for your compounding period, and you're done. Just grab the decimal and convert it to a percent. And then wash your hands and walk away. All right, so, again, it doesn't matter what the money is. The book spends about a page and a half going through a problem like this where the principal is like $52,322.83. So the numbers are big, they're nasty, they're annoying, they're all over the frickin' place. And in the end, they could have just pulled this number right off the table. All right? So, find APY for an account that pays, let's say, 7% compounded semi-annually. Notice I didn't even bother to give you the money this time. I didn't give you any P. Because you guys now know it doesn't matter. Alright? Don't get tricked into trying to use that principle when you go to calculate APY. It doesn't matter. So, for this problem, what you're going to do is you're going to say, oh, great, APY. I just need to know what page and row to look on. What page am I going to go to?
3.5.
3.5, because you're going to say 7%, and since this is semi-annually, you're going to divide by 2, which is 3.5%. What row are you going to go to? Remember, this is annual percentage yield, so there's 1 year. In 1 year, how many times are we going to compound our interest? Twice. So we're on row 2. So on the 3.5% page, row 2, column 1, what do we find? And what are you going to tell me the APY is? Exactly. Pluck this number off and convert it to a percent. The APY is 7.12%. Enjoy the shortcut here, folks. This one makes life a lot easier. And I know on the homework there's at least one, if not 2 problems that ask you to calculate APY. Folks, don't forget this nice little shortcut. Right? And again, if you go back in the book is going to, it's going to throw you a bomb left and right on this one. So just be ready. All right, so that is dealing with column 1. Now, what we need to do is figure out how to do column 2. What is the title of column 2 in all of our tables say?
Present value.
Present value, right? So, what I start here is by saying, okay, imagine if you will that say, in 4 years, that you're going to need to buy, say, Oh, what's going to break in my house in 4 years? A new refrigerator. Okay. I need a new fridge in 4 years. All right. How much am I going to spend on that fridge? $2,000? Okay. I need $2,000 in that 4 years, right? So I'm going to assume that prices of refrigerators don't change too terribly much in 4 years. They may not, kind of hard to determine. But I'm going to assume that I'm going to need $2,000 to buy a new one. My question to you is, how much should I invest now into an account that pays, let's say, 5% compounded semi-annually? To reach my goal. In other words, how much money do I need in the present, i.e. the present value, so that in the future, 4 years from now, I will have $2,000 and I can just walk over to the appliance store, whatever it is in 4 years, which it'll probably be Walmart, and I'll say, $2,000, blam! I'll throw it down on the table and I'll make some salesperson show me everything that I can get for $2,000 and I'll pick the best one there. Right? And note that here I am earning interest for myself instead of going out and buying the refrigerator in 4 years and having to borrow the money and paying interest on it. Right? I mean, this is sort of like planning for life 101, right? So, again, finding an account that pays 5% compounded semi-annually, good luck with that, but I have my money sitting in an account that pays 3% compounded daily.
Well, where do you get that one from?
University of Iowa, credit union.
Why would it only go down to 6% then?
Hmm?
Why would it only go down to 6%?
Because these tables were made back when interest was real, back prior to 1995.
Oh, okay.
Where you actually get some money for your...
There are table entries for that are less than 6%, but we would have to find a different table.
Okay.
Annoying book hasn't updated this stuff in a while. Whatever. But I could crank those out for you if you need them. Anyways, so my question is, how do we go back to the present? Again, think of me as Michael J. Fox, and instead of going back to the future, I'm going back to the present. Right? So first I'm going to go buy myself a DeLorean, and I'm going to get, 6.2 gigawatts of... Is that what it was? I can't remember. 2.2? Anyways, sorry. That movie's probably before most of your time. Alright. The key to this problem is that when you are trying to find the present value instead of the future value, instead of using column 1, use column 2. Everything else about column 2, exactly the same. Which is really, 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 really nice. So, technically, from now on, because now you're going to know how to use more than just one column, the first thing you should do on all these problems is read the problem and then tell me which column you should use. Column 1 or column 2. Right? So you read the problem and you say, am I trying to figure out how much money I'm going to have in the future, or I need to know how much money I need to have in the present to get to the future? Because that's the difference between column 1 and column 2. Alright? So, from now on, every problem I do, I'm going to start by saying this is a column 2 problem, because I'm trying to find the present value. I'm trying to go back from the future. But everything else that we were doing in column 1 applies to column 2. So P is the $2,000 that I want to reach, okay? page I'm going to go to, do exactly the same thing like this was a column 1 problem. So, 5%, and what am I going to do with 5%? Divided by 2, why 2? Because it's semi-annually, so we're going to divide by 2, and you're going to tell me to go to the 2.5% page. And what row am I going to go to?
8.
Because
4 years.
4 years. And I'm going to compound it twice a year. There are 8 periods. So, here we go. 2.5%. Be careful, make sure you read column 2 and not column 1. But go to row 8, column 2. What's the first thing you notice about all the numbers in column 2? They're all less than 1. Why is that? Why are all the numbers less than 1?
You're going backwards.
Because you're going backwards, right? Because we need to have a number that's less than $2,000, right? Because if I invest more than $2,000, so let's say I invest $2,200, and I wind up with $2,000 at the end, what happened? I was losing money, but I invested it, so I should be earning interest. Okay, so you guys understand how interest works, okay? You know how money works. If you put money in the bank, there's going to be more in the future, right? So if you tell me that this number is somehow more than $2,000 and just happily march on to the next question, I'm going to be mildly disappointed in you. All right? Because this number, you know, has to be less than 1 or less than 2,000. And in order to get a number less than 2,000, you must multiply by a number that's less than 1, because that's what happens when you multiply by a number less than 1, is that the value you get is smaller. All right? But the process remains the same. Take your principal value or your first starting value, multiply by that $2,000. 16414. So, if I want to have $2,000 in 4 years, I will invest $1,641.40 today, and that 5% compounded semi-annually account will get me to that $2,000. All right? So, what? Yeah.
4 years, just gig.
Again, with interest rates as crappy as they are, right? I mean, this is what you have to deal with nowadays. It does kind of suck, but again, life in the city, right? All right, so let's do another one of those just to be safe. All right, so my business will need a new, let's say, $35,000 truck in 6 years. All right, so I own some sort of construction business, whatever it may be, and I know, because I am a well thought up business person, that in 6 years this truck is just not going to cut it anymore, right? The engine's going to be fried, the brakes are going to be fried, and I'm just like, screw it, I'm going to trade this thing in or give it away, whatever. I'm going to buy a new one for my business. So, I have an account that pays 10% compounded quarterly. When you own a business, you're often made available to investments that are a little bit shadier than standard individuals. So I won't tell you where this account is, but you can probably rest assured that it's on an island somewhere.
Right.
In a country that very few of us will ever get to. Anyways, my question is, how much do I put into this account today to reach my goal? In other words, I know what my future is. What do I need in the present? All right? All right, so again, this should be very similar to how you guys start attacking homework problems, because the homework problems will sound very similar to this even, right? I mean, trying to pull some of them out of there to some degree. So your first step is this a column 1 or a column 2 problem? 2, because it's asking me to reach a goal. It's asking me how much do I need now to get somewhere, all right? So, this, there we go, is a column 2 problem. So when you go to your tables, please make sure you look up the right column, okay? What's P in this problem? How much money I need, P in this case, is $35,000. What page am I going to go to? And why is it 2.5? It's a 10% interest per quarter. Quarterly, divide by 4. I'm going to the 2.5% page. What row? How many years? 6 years. How many quarters per year? 4. There are 24 periods, so you go to row 24. So, what's my table? 5529, is that what you said? Okay. Multiply by your 35 grand. How much do I need to put in there?
19,351.5.
What was that?
19,351.5.
I don't even need 20,000 bucks to make it to my truck. So, the difference, folks, between business investments earning 10% and individual investments earning,
Correct.
yeah. All right, so this is not uncommon. Again, most businesses that are, relatively solvent and not living from, month to month to make payroll, this is what they're doing, right? They're looking at their inventory, they're looking at their assets and saying, how much longer are these going to be worth it, right? And this is, for a construction company, a $35,000 truck, that's, it's probably a cheap truck, right? I mean, if this was a real construction company, we may be buying a crane. How much do you think a crane runs for?
200.
It starts at $250,000, right? You can go up to 1.5 million on buying a mid-sized crane. You buy one of those big ones, you're literally spending $10 million, okay? Right? I mean, this is business, right? I mean, that's why business, you gotta have money to make money, right? Because you gotta go out and buy a $10 million frickin' dollar crane in order to start a really powerful construction company, right? Good luck, right? This is why you start small and work your way to big in theory. All right, so now, this is always fun. So, just a generic problem. And you got to tell me what to do. All right, so I invest $19,351.50 into an account that pays, how about, say, 10% compounded quarterly. How much will I have in, say, 6 years? Shh, you don't know that yet. All right, so in theory, if you guys were paying attention to the last question, you shouldn't have to do anything for this problem, right? Because what did we do on the last problem? We figured this one out already. But let's imagine that we didn't do that, right? So, these are not the droids that you guys are looking for. You have forgotten the problem we just did a couple of minutes ago. How would we do this problem, right? So, I did a Jedi mind trick on you. You guys forgot this problem. It doesn't exist anymore, right? So, how would you go about doing this problem? Okay, so let's attack this problem like we didn't do this earlier problem to begin with, right? So your first step in all of our problems is, which column is this, 1 or 2? This is column 1, because I'm trying to start in the present and get to the future, right? So, what's my P in this problem? $19,351.50, the amount of money I put into my account. What page am I going to go to? %. Divided by 4 because it's quarterly, you're going to the 2.5% page. And this is completely different than the problem you just did before because you forgot it. And what row am I going to go to? 6 years, 4 quarters per year. There are 24 periods. Again, this time we are using column 1. So what's our table entry this time? 8087 multiply by your $19,351.50. And what does it turn out to be?
$35,001.06.
It's close, right? But is it exact? No. Why isn't it exactly $35,000? Because we use the table, and what are we always doing in the table? Approximating, right? If you take an approximate number, this is an approximate number, and multiply it by another approximate number, the more times you approximate things, the worse your numbers get. Okay? They should be close. I mean it's $1 away, but it's not too far off. Okay? But don't, your gut instinct is that it should be exactly 35,000. But that would be only if we did this problem exactly. And you guys know we're not. So just punch it in there, make sure it works out, all right? In other words, column 1 and column 2 are actually checks of each other, right? If you want to see if a number looks right, just apply column 1 to it and it should get you back to where you started, right? If you're using column 2 first, slap column 1 onto that number, and if it doesn't get you somewhere close to where you started, you know you maybe did something wrong, all right? But when the text asks you to check and answer, this is how you do it, right? Check and see if this number is correct is sort of like saying, take this problem, work it backwards, right? In other words, use the other column on it, see where you go, all right? All right. Okay, so column 1 and column 2. All right, so let's try another one. I need $225,000 to buy a new house. I'm kind of getting tired of the one I'm living in. Isn't that how it works? Or more appropriately, I'm getting tired of fixing the current house that I live in, because anytime you buy a house, you have to constantly fix it yourself or pay somebody to do it, which is even worse. All right, so I need $225,000 to buy a new house. Say in how many years? In 10 years. In 10 years, comma, and I have an account that pays, say, 6% compounded monthly. How much do I need to invest today so that I will have that much money in 10 years? Of course, what I didn't tell you is that in those 10 years, that house is going to be in, France. Because I'm just going to retire and move out of the country and start working in France for whatever reason. Of course, I don't know a lick of French, but... Well, that's the other thing I have to do. Learn some French. Scary thing is that I have a friend of mine I play softball with who just did that yesterday. He just flew to Lyon in France. He retired from his programming job at the University of Wisconsin, and he became a contractor in France. I'm like, I didn't even know he could speak French. Learned something new. All right. Anyways, how are we going to do this problem? What's our first step? Column 2, because I'm giving you the future and I need to get back to the present. All right, so this is a column 2 problem. P is your future value. Again, remember when you're starting in column 2, P is not what you're starting with. It's really where you're trying to end up at, or it's your future value. Not quite $250,000. What page am I going to go to? Well, what's the percentage that I have? 6%. What do I do with that 6%? Divided by 12. What's 6 divided by 12? 0.5, or a 1/2% page, i.e. the very, 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 very first table. What row am I going to go to? Technically, what row would I have to go to, guys? Right? It's 10 years. You're going to multiply by 12. Uh-oh.
There's no way to.
How would you try and handle this problem? 50 twice and then 20, right? I mean, in theory, you could do it. At this stage, folks, if this happens on a test or on a homework problem, what would you do? You would bring the test or the homework problem to me and say, what the, Marshall? And I'll say, oh crap, I didn't mean to do that. And I would go back and change the numbers on you and say, oh, I meant to say that was 4 years, not 10 years. Or I meant it was compounded quarterly instead of monthly. Please, if you find yourself not on the table, stop. Okay? I mean, check yourself first, right? I mean, go back to the problem and say, wait, did I really do this correctly? And make sure that it says, yes, 10 years, and he did say monthly. I know that every year there's going to be 12 periods, so this has to be 120 periods. This problem doesn't work, okay? When that happens, don't worry about it, okay? Just come and tell me, and hopefully I will say, oops, and we'll fix it, okay? All right, so it's just me trying to point out to you that I'm going to try and keep things on the tables that you can work with. And if I don't, let me know, all right? All right, so in this problem you would say, oh crap, not on tables. And potentially what you would do is you would go out to the internet and you would type in, 0.5% compounded monthly, you'd look for this table entry to go further, and if you could find it and do it yourself and actually get it outside of the table and get extra credit, that's the sort of thing I would give extra credit for, is if you could go work off the tables by searching the internet for the continuation of all of these numbers, because they're out there, right? These are just, somebody punched the numbers in a calculator and then wrote them down. That's all there is to it. All right? Okay, so don't worry about problems like that. But let's suppose that I change this after you figure that out and I say, whoops, I meant to say quarterly. So if I meant to say quarterly, how does the problem change? Yeah, 4s, not 12s. Everything else stays the same, right? So if your page was 6% divided by 4, you go to the 1.5% page. Your row would be 10 years times 4. You would go to 40 periods, or row 40. And now this is a problem that you can do. Whew. Thank you for fixing your screw up, Marshall. Move forward. And I did do this one for the test, folks. I did. I mean, the first person who handed in the test didn't tell me that they couldn't do the problem. They just handed it in and left. They just left that problem blank. I mean, it was my screw up, but you know, it's like, well, okay. Anyways, so table value 5513 times my $225,000. How much would have I needed to invested today in order to be able to buy my French chateau?
$124,042.50.
Not too bad, right? A little bit under 125,000. I could probably drum that up, right? Sure, I'm a teacher. I've got money sitting everywhere. Ask the governor; he'll tell you. Alrighty. So, the homework, the evens at the end of chapter 12, 2 through 30. I think there's only up to 30 this time. Yep. 2 through 30. 2 through 30 even. Remember that 32 is extra credit.